Welcome back, dear students, solving another numerical problem on engineering mechanics. Problem set 2.4, solution to 2.57. Look at the arrangement here. In the bar of the square frame, this is a square frame, A, B, C, D, A. AB is a bar, BC is a bar, CD, DA is also are bars, BD is also a bar, AC is also another bar. AC and BD they're freely passing through each other at E, right? Now a tensile force P is produced by tightening a turnbuckle F. This is a turnbuckle F. I will explain what it is. If you look at the bar AB, this is not continuous. This passes through this turnbuckle. Means from this point to this point is connected to this end of the turnbuckle, and from this point to this point is connected through the turnbuckle at this point. You can rotate this turnbuckle clockwise or anti-clockwise. Means if you tighten this, if you rotate this clockwise, this part from here to here will be tightened, from here to here will be tightened. If you rotate it the other way, this part from here to here will be made loose, and from here to here will be also made loose. Means you can adjust the tension in the part AB. So what is a turnbuckle? It is also called a stretching screw or a bottle screw. It is used for adjusting the tension or the length of ropes or cables and tie rods. Now it is made up. It consists of two threaded eye bolts. And there is a thread here, there is a thread here, and there is a bolt connection. So if you rotate this turnbuckle to one side, let's say clockwise, this part and this part will be tightened, means the tension in the parts will increase. If you lose it by turning to the other side, the tension in this part and this part will be reduced. So in certain situation, so consists of two threaded eye bolts, one with a left hand thread and the other with a right hand thread. Suppose the thread here is left handed, the thread here will be right handed. Now, so if you look at the number of concurrent points in the system are 4. 1, 2, 3, 4. At this point, BD and AC are passing freely. So there are 4 concurrent points A, B, C, D. But the number of unknown forces are less at point A, at point B. So we'll first begin with either point A or point B. Apply sigma x is equal to 0, sigma y is equal to 0. And as given in the statement, the tensile force P is developed in the part AB by tightening this turnbuckle, P to this side, P to this side. If you consider these 2 points, if you consider this point, the same P will be to this side. If you consider this point, the same P will be to this side, right? Now, now in solving this kind of problems, you have to have some imagination which bars will be under contraction and which bars will be under extension. Then applying sigma x is equal to 0, sigma y is equal to 0 to the points where there are less number of forces, reduces the problem to a simpler situation. Now that is what I am going to explain. So P is the tensile force developed in AB. Now So when this turnbuckle is tightened, the tensile force developed in AB is P. P on this side and P on this side. If you consider point A is to this side, if you consider point P is to this side. If you consider this point, P is to this side. If you consider this point, P is to this side, away from the point. Now the question is, due to such a situation, the bar AC is under contraction. Due to the tensile force P here, the bar AC, when you are tightening the rod AB due to the turnbuckle, this AC, this bar AC will try to contract in length like this. So bar AC is under contraction. Therefore, the tensile force S5, and therefore the tension developed in the bar AC, let it be S5, is towards the joint A. This is taken as the fifth rod, so S5 will be towards the joint A. Similarly, S3 in AD will be away from the joint A. Similarly, S3 in the bar AD is away from the joint A. AD is called the third bar. It will be, let it be S3. So it will be away from the point A, because AD will, by contracting this, AD will try to expand. So the axial force S3 will be away from the joint A. So once that is known, let us apply the free body diagram, draw the free body diagram at A and apply sigma x is equal to 0 and sigma y is equal to 0. So at A there are three forces, S3 away from A, S5 towards A, and for the point A, P is away from A. So I have drawn the free body diagram at point A. So as you can see, point A, P is to this side, S3 is to this side, S5 is towards A. So sigma x is equal to 0. If you take the component of S5, that will be this component, that will be S5. This is 45, so this will be 45. So this one will, from here to here, will be S5 cos 45. So S5 cos 45 will be equal to P. Then only sigma x will be 0. So take cos 45 to this hand side. So S5 becomes root 2 times P. It is a force of compression. Similarly, if you apply sigma y is equal to 0, now the component of S5 along y-axis will be this one, from here to here. This one is in front of the angle, so it will be S5 times sine 45. S5 times sine 45 is your S3. Put the value of sine 45. So S5 into 1 by root 2. So, so now put the value of S5. That is root 2 times P here. So root 2 cancels. This is equal to same in magnitude as the force P due to the turnbuckle. So S3 is equal to P. That is a tensile force. Now, then let us apply the free body diagram at B. Now, then apply the free body diagram at point B. Similarly, the bar BD is also under contraction. How? If this turnbuckle is tightened, the length AB will be reduced. Means if you rotate this turnbuckle clockwise, this part will be shortened in length, means this part will get inside the turnbuckle. This part from here to here will get inside the turnbuckle, means the overall length of AB will try to reduce, means it is under compression. So due to that, the bar BD will try to expand in length. So the bar BD, similarly the bar BD is also under contraction. Sorry, it will be under contraction. When this is tightened, so S4 in BD is towards B, and bar BC is under expansion. So S1 in BC is away from the point B. So that is the understanding. Now let us apply the free body diagram at B. As you can see from here, the force P, the same P, considering the point B is away from the point B, and S4, because this is the bar number 4, is towards the point B, and your S1, that is in the bar BC, is away from the point B. Now apply sigma x is equal to 0. So if you take the component of S4, this is 45. If you drop a perpendicular here, this angle will also be 45. So this one will be the x component of S4, that will be S4 cos 45 to this side, that is opposite to P. So S4 cos 45 is P, so S4 is equal to cos 45 goes to this side, so root 2 times P, so it is a force of compression, it is compression in nature. Similarly, if you apply sigma y is equal to 0, this is your S4, so this component from here to here is equal to S4 sine 45, which is equal and opposite to S1, to make sigma y is equal to 0. So S1 is equal to, put the value of S4 from here, root 2 times P, sine 45 1 by root 2 cancel, so equal to P. So S1 is P, that is it, also tensile in nature. And then come back and apply the free body diagram at point D. Either you apply here or apply here, one and the same thing. I am applying here. So S4, this S4, if you consider point B is towards B, if you consider point D, it is towards D, same S4. So same S4. So this is your point D, S4, this is 45. S2, S3. Now apply sigma x is equal to 0. The component of S4, one will be this. This is 45. So this is also 45. So this much will be S4 cos 45. That will be equal and opposite to S2 to make sigma x is equal to 0. So S2 is equal to, I have put the value of S4 cos 45, root 2 cancel, equal to P is tensile. Now no need to apply sigma y is equal to 0 to find out S3, because it is already found out, but still if you want to, you can do so. Sigma y is equal to 0. The component of S4 along y-axis from here to here will be S4 sine 45, because it is in front of the angle. So S4 sine 45 is equal to S3. I put the value of S4 sine 45, root 2 cancel, is equal to P. So it is already calculated in equation 2. But still, if you want to calculate here, you can calculate here also. So that is all about. While answering such questions, you have to first analyze which bars are under compression and which bars are under extension. Then apply the free body diagram to the points where there are less number of force associated. So if you find it useful, please give back your comments so that I can improve certain things for better understanding. And if you feel like, you can subscribe and pass on to your friends aspiring for GATE examination and other students and students of mechanical and civil engineering pursuing their BTech degree in different colleges in India and abroad. Thank you.